In this short video, I will explain how to estimate reference intervals using indirect method RefineR. We have two methods to estimate reference intervals. One is direct method and the other one is indirect method. And among indirect reference interval estimation methods, RefineR is considered a highly accurate estimator among the other methods. Before starting the practical tutorial, I would like to take your attention to a couple of points to be considered. To achieve the better results, the pathological fraction in our data should be lower than 20% and the total amount of our data should be at least 5,000. And also the pathological fraction should ideally be less than 50%. And for skewed distributions, which is generally shown in our laboratory data and populations data, we have to assign Modbox Cox parameter into our code. I will show you in our example. And also we can calculate confidence intervals of reference interval limits. To estimate these confidence intervals, we have to conduct bootstrapping. And for this bootstrapping protocol, minimum of 200 iterations is recommended to be entered in the R code. So, how to estimate the type of R distribution, if it is skewed or not? Actually, there is a formula distance ratio as given here, which is considering mode and reference limits, lower reference limits, and upper reference limits, and the ratio. And when this ratio is higher than 0.75, it is considered as a normal distribution. When it is between 0.25 and 0.75, it is considered as a skewed distribution. And when it is lower than 0.25, such a ratio is considered as a heavily skewed distribution. So let's go on with our tutorial. Okay, let's start with our data structure. We have two columns. One is gender column and the other one is ferritin column, contains ferritin values. If you structure your data just like it, you can easily use my code to estimate your own reference intervals. So let's go on with RStudio. When you open your RStudio, you will see exactly the same page like me. Here is the area that you write your script. Here is the console screen and environment and plots shown here. So please copy and paste the R script I shared downwards the video. Here I copy and pasted this R script. When you firstly paste them, maybe you get a warning from RStudio that let me install these RefineR and ReadXL packages. You just click on please install and afterwards it install. It takes a couple of minutes and afterwards everything is all right and we can run these codes. So at first step we have to run these 4 rows to import our libraries, RefineR and ReadXL packages. So afterwards I have to read my Excel file. So please copy and paste your path of the data just right here. Here is my data's name is ferritin gender data and it resides in reference interval norm study which found in my desktop. So I run this code and import my data. Here you can see in environment, you can see my data. When you click on this data variable, you can see all the data you imported, ferritin and gender data. Let's go on with our script. In second step, I have to select my column, ferritin column, just right here, and from my data and assign these data to a new variable, ferritin values. Let's run this. Okay, I assign a new variable named ferritin values, which contains ferritin values from my original data. In this example, I don't discriminate gender, so I included all genders and find out reference intervals fit for both genders. I would like to use Modbox Cox for my example. I know that my data have skewed. But I would like to keep and bootstrap as 5 for demonstration. Let's run this. I use find RI function from RefineR. This function use my ferritin values and modboxcox model because I have heavily skewed distribution and use bootstrapping iteration as 5, but it is not appropriate. I have to say that you use at least 200 iteration for n bootstrap for a reliable confidence intervals for your reference limit. We use and bootstrap to estimate our confidence intervals for upper and lower reference limits. So for getting a reliable confidence intervals, we have to use 200 for this bootstrapping protocol. You can assign any seed for this code. It is not very important thing. It keeps your code be reproducible. So after this code finishes its execution, we will assign these results to a new variable named result. So we are waiting our studio to run this code. Here you can see a stop button. If you click on this interrupt, if you click on the stop button, you will interrupt this R code execution. But please wait after it finished. So it finished, and you can see the ferritin values just right here, a new variable, and also the results. Actually, this code gives me results. So let's print our results. I run this code, and in the console screen, you can see our results for lower reference limit as 3 and upper reference limit as 465. So in this example, I selected 2.5 percentile and 97.5 percentiles. Generally, reference intervals are containing two reference limits, upper and lower reference limits, but sometimes we use a single reference limit as reference intervals. And in such examples, you have to use a single reference, single percentile as 0.95 as a 95th percentile. But in our example, we use 2.5 percentile and 97.5 percentiles. Okay, let's run this plot code and plot our reference intervals within our data. As you can see here that we have a highly skewed distribution and we have lower and upper confidence limits. And you can also right click on this image and you can save this image as PNG file, or you can just copy this image and paste this image wherever you want. And in the other example, I will give about the selection of the genders and estimating reference intervals for the selected gender. So at first step, I would like to select the gender column. So I just run this code. I select gender column from my data and assign these data to gender data. So in the second step, from gender data, from this gender variable, I select male gender, and from ferritin values, I look at the gender male and assign these values to male data. Let's run this, and you can see here that male gender ferritin values. Afterwards, similarly, these are box-cox models for box-cox models when you have normal distributions. But I have a very heavily skewed distribution, so I will go on with mod box-cox. In this example, I will estimate male genders, ferritin reference intervals. So I would like to keep and bootstrap as 2 for as 5 for this example for demonstration purpose. But as I said before, you have to select at least 200 for a reliable reference interval estimation. Okay, one of the most important thing about this estimation protocol, uh, if you would like to get the best results from this protocol, the pathological fraction in your data should be at least 20%, and your overall sample size should be minimum 5,000. But my original data contains 5,700 approximately results. But when I select the male data, it's just 2,600 data. So therefore, I just go downwards 5,000. It is not an appropriate data, but it is just a demonstration. So please be careful about it and select the data contains minimum 5,000 results for your selected analyte. And ideally, at least the pathological fraction in your data should be at least 50%. It is the another important thing about this estimation protocol. Here in this example, I can visually see the distribution, but you can also calculate the distance ratio for this. So, in this example, I also printed my results for reference intervals. Let's plot them. Also, see our new reference intervals for male gender. As you can see here that we have also a skew distribution and 525 and 29 as lower reference limits and their confidence intervals. But we use only iteration of 5. It's not appropriate. You have to use at least 200 iteration for n bootstrap, and you have to use at least 5,000 results for your data. Please be careful about it. So in this short video, I explained how to use this RefineR package to estimate reference intervals using an indirect method. If you have any questions, you can send mail to me and I can happily answer your questions. Thank you very much.